Hello everybody. In this video we are going to discuss about the critical section problem in the operating system. First of all, what do you mean by this critical section? So let me tell you, this critical section is a segment of code where we are able to share the variables and we are going to share the resources. So whenever the process is in critical section, the atomic action should take place. That means only one process can execute in the critical section at a time. Now to understand it more precisely, let me take one example. Now here, as you can see on the screen, I am considering a system where we are having n processes. For example, the process name we have given as P0, P1, P2 till Pn minus 1. Now each and every process is having certain section of code, okay, or certain segment of code which is known as critical section or critical region. Now this critical section or critical region, as I have told you, this is a part of the code where we might be changing some common variable, might be updating the table or writing into the file or reading from the file and so on. Okay, so whenever we are performing certain kind of operations, then we can say that the process is in critical section. And as I have told you, whenever the process is executing in the critical section, it should be mutually exclusive. That means we are not allowing any other process to execute in the critical section at the same time. Okay, so let us see this one with the help of a code. So if you see the general structure of a process, so it might be something like this. It is having do. In the loop, I am having the different sections, like we are having entry section, we are having critical section, we are having exit section, we are having reminder section. Until and unless this condition is true, it is going to repeat these sections again and again. So as far as this entry section is concerned, it is basically controlling the entry of process into the critical section. That means it is going to decide which process is going to enter the critical section, because the critical section should be mutually exclusive in nature. Fine. Then comes the actual section called critical section. In this section, we are going to perform the actual operation. As I have told you, it is holding a set of code which is going to perform certain critical operations. Fine. Then we are having the exit section. This exit section is going to release the access. That means the process is coming out of the critical section. That means it has finished with the performing of certain critical operations. Fine. And lastly, we are having the reminder section. This reminder section is having the rest of the code. That means the other part of the program. Okay. So here, as you can see, this is the entire structure of the process. And as I am telling you right from the starting of this video, that here each and every process is having its own critical section, and we cannot have two different processes at the same time in the critical section, because it need to share the resources. And if two processes are entering the critical section, that means it may lead to the... After seeing this critical section problem, now let us discuss about how to solve this kind of critical section problem and what are the requirement for providing solution to this kind of problems. So basically we are having three requirements for the for finding the solution of the critical section problem. The first one comes in the form of mutual exclusion. That means whenever a process is executing in the critical section, we are not allowing any other process to enter the critical section. Okay. This is the one solution. The second one is progress. Think, for example, there are no process which is executing in the critical section. So at the when there are no processes executing in the critical section, and if certain process wanted to enter the critical section, then we can check whether that process is executing or whether that process is in the reminder section. If it is not there in the reminder section, then we can allow that process to enter the critical section. Let me be more precise on this progress part. Think, for example, there is a process P1. Okay, and so far there are no process in the critical section. So now if process P1 wanted to enter the critical section, the first thing what operating system is going to do is to check whether the process P1 is in the reminder section. If it is in the reminder section, we cannot allow it to enter the critical section. If it is not there in the reminder section, then we can allow the process P1 to enter the critical section. Okay, this is the second requirement for finding the solution of critical section problem. The third one is bounded waiting. So bounded waiting, because there might be certain limit where the process is allowed to enter the critical section. Okay, that means once the process is requesting to enter the critical section, okay, so we should keep in mind that no process is postponed indefinitely before granting the request. Okay, and one more point I wanted to specify here is that the critical section in the operating system are basically handled either by using preemptive kernel or non-preemptive kernel. Okay, preemptive kernel is allowing process to be preempted while it is running in the kernel mode, and non-preemptive kernel is not allowing the process to be preempted. I hope you understand the critical section problem and the basic requirement for finding